Okay, so let's go ahead and finish the rest of this lesson. It says, what is the circumference of each circle from the page before? So first, I always want to write the formula for circumference. We know that circumference is equal to 2 pi r. Sometimes we can also use the alternative uh, formula, which is just pi times diameter. It really just depends on what you're used to using. And in this case, from the previous page, we actually have the diameter handy. So I'm actually going to just use this formula. And we know that I'm going to write C of small is going to equal, well, the small circle had a diameter of 5. So it's really just 5 pi. Okay. The C of large, which is the circumference of the large circle, had a diameter of 10, which means it's just 10 pi. And you could write it in units. Just please write units. And you could see that the circumference of the large circle was twice as large as the circumference for the small. So the theme of the lesson really is why was the circumference 2 times larger? Right? The overall circumference is kind of like 2 times larger, but the area was 4 times larger. Keep thinking about that. We're about to answer that. How many times bigger is the circumference of the bigger circle than the small circle? The larger circle's circumference is 2 times larger than the small. Okay, so this is the theme. Here we go. Fill in the blanks. When you enlarge a figure with a scale factor of 2, the side lengths and the circumference double, but the areas quadruple. I used an exclamation mark. You shouldn't really use that there, but the areas quadruple. And then the angles, did anything really happen to the angles of the triangles? Does a scale factor ever affect like the corresponding angles? The answer is the angles remained the same. Okay, I hope you understand that. Again, the reason why when you double the side lengths that the perimeter doubles is because it's very simple. If you take a square that's a 1 by 1 by 1 by 1 and you, let's say you triple it, class, you then end up getting a 3 by 3, right? You could see that the perimeter would triple. The perimeter used to be 4 here, and now it's 12. But you could also see that the area is not triple. The area is 9 times larger in my example. And it's simply the scale factor squared. Okay. We could definitely discuss this more in our office hours for those of us that are still kind of not misunderstanding this. But it's the scale factor squared is how area is affected. Areas change, right? So it's really, really important. 10. Draw a diagram to solve. A circle with a radius of 3 centimeters is enlarged, so its radius is now 6 centimeters. Okay, this is kind of like the same thing. You're doubling the radius, so you can kind of already tell what's going to happen. It's literally the same process. So by what scale factor did the circumference increase? Okay, so let's just see. If I take a circle and it has a radius of 3, and then I take another circle and I make the radius now 6, you could see that the area doesn't look 2 times larger, right? But the circumference will be. So So it's kind of simple, but the circumference will be twice as large. Twice as long. But by what scale factor did the area increase? The area is going to be 2 times 2, which is 4 times larger. We already know that. We don't even have to calculate it. Explain why this makes sense. Area is two-dimensional. And the scale factor affects the area. The area by the scale factor squared. Okay. So let's just double check and make sure that this is right. We know that a circumference by definition is 2 pi r. So if we were to calculate it, this circumference would be 2 times 3, which is 6 pi, whereas this circumference would be 2 times 6, which is 12 pi. So we know that these circumferences are 2 times as large. But in terms of area, area is different because area has the radius squared. So in this case, the area is going to be r times r, which is 3 times 3, which is 9 pi. Sorry. And you should write units squared. This is units. This is units. And in this case, the area is going to be 6 times 6 times pi because it's r squared. So it's 6 times 6 times pi is going to give us 36 pi. Not a coincidence that this is 4 times larger. 2 times. Okay. This is a concept we've talked before in the past. This is on scale factor and how scale factor affects area. So definitely give this a review and let me know if you have any questions. See you later.